Dear colleagues, we start the last session on this platform. We are going to have Greg Wolfen, Salavat Nabi from Secure Key Company, and they will be talking about blockchain technology. So we're going to have Greg Wolfond, and he's going to talk about platforms we are creating. And if there are some technical questions after the presentation, I will be ready to answer in Russian.
Okay, thank you. So my apologies if this presentation is in English. But I'll tell you a little bit about the experience that we're having in Canada with digital identity and how we're dealing with cyber identity issues. No. Next. Let me try yours. One moment. Maybe I'll tell you. All good? Thank you. Okay. So SecureKey is a cyber company. We're founded in 2008 in Canada, and we have a lot of investors. All of the national banks invest in us. The telcos invest in us. Intel is a big investor, as are some of the card networks. And we're really focused on solving this problem of identity. How do you know who you are when you show up somewhere? How do you prove who you are without having to remember that uppercase, lowercase? Code, you take the code home, they give you a password, but you could never remember how to log in when you come back 6 months later. So what they did is they instituted a program for all the departments. So for tax, for unemployment, for 80 different departments, where you can now show up to government and log in with your financial institution. So that saved the national government about $600 million a year of cost, because they didn't have to manage user IDs and passwords. And things like bank credentials, people remember, you know, your money is safe at your bank, so they remember your bank credentials. Hugely popular program. We run it for the national government. It's growing at a great rate. About 50% of adult Canadians use the service. And now the service is rolling out to the provinces. So we have provincial states, so Quebec, Ontario, and British Columbia are the biggest states for using the service. So I can now show up there and get services from the province by logging in with my bank. It's a federated authentication. And one of the things, when we heard the session this morning, where they talked about government working with bank, it's a huge cost savings for everyone in the infrastructure. Because banks want to do this to protect their customers, to add more value to their customers. And government doesn't have a credential that people remember. If I only use it once a month or once every 6 months, it's true for healthcare as well, like in some of the healthcare problems. So the other thing we do in Canada is we put a chip in some of the driver's licenses. So in British Columbia, which is our westernmost province, they had a problem with fraud. So similar to Russia, we have free healthcare. And what they found was people were coming to Canada and pretending to be someone else in order to get the free healthcare. So they had 8 million health cards for this one state running, but they had 4 million people. So they started to realize that's a problem. So how do we make that more secure? And we actually put a payment card, an EMV chip, inside the driver's license, which is now called a services card. So you can use this for healthcare, and you can use it for services. But it means people aren't bringing their brother, their sister, their cousin into the country to be able to use free healthcare services, because you have to have a card that's vetted. So the latest thing we started to work on was not just authentication, but also full identity. So a lot of conversation this morning about public-private partnership working together to get this solved. To solve identity, it's not just a digital problem. It's not just online, you show up somewhere to get something done. You show up at your bank and you want to prove who you are with a driver's license or a passport. You show up on the call center and have to prove who you are. And all of these are broken. Right? There's a lot of conversation about IoT devices and what IoT will do. When I checked into my hotel here last night, they photocopied my passport. In the United States, when I go to any hotel, I show my driver's license. There's an IoT camera behind the desk recording all of that, and it's a not secure device. So if someone breaks into that camera and is able to take the pictures and the driver's license off it, they can make a copy of my driver's license, put a different photo on the front, and they become me for identity fraud. So there's a role that government has to play in how do we make these systems more secure. And our learning from work we're doing in Europe, work we're doing in the United States and in Canada is, in the end, to solve this that works in call center, in person, online, we have to have government and private sector working together to make it work. So when we talk about kind of the fraud that we're seeing in North America, and I talked about the driver's license before. The driver's license is what we use in North America. In Canada and the United States, we're using driver's license as your identity document, but it's a piece of plastic, right? For $30, you can make a great copy and become anyone you want to. And some of the folks think that biometrics will be the answer to this. So just a biometric is good enough, but our answer is just a biometric by itself is not good enough. Because if I have a fake document and I match the picture on my document, the bad guy gets in. In India, where they're using a fingerprint biometric, and they said biometric is the answer, they're realizing people can lift your fingerprint off a picture on Facebook and put it on a sensor in India, and it passes the test to go through. So the answer in the end of all this in the cyber world is that you need all three. To build a really strong cyber solution where someone can prove who they are, we're going to need a what I know factor, like a PIN with your card or like your bank login that you remember. We're going to need a what I have, which very often in North America is your cell phone, to prove I have this device, that the SIM is in the device, that the location of the device is where it is, and also a what I am, which is a biometric that you match the face. Some of the things Dimitri talked about this morning, I can match the face on my passport or match the government ID that I'm on. And at different points, depending on what we're doing, we need different ones of these levers to pull. So that's what we're doing in Canada, is building a what I know, what I have, what I am, that takes data and security measures from government, from bank, from telecom, and makes them work together in a seamless fashion. So the banks in Canada invested, all the 7 major banks in Canada that bank 96% of the population, they all invested in us to build the new solution. The new solution is built on top of blockchain solution for sharing data, but generally what it's trying to do is put data in the consumer's hands. So the consumer has their data and is able to share their data. In this picture here, this is the Verified Me app. But you can see in the middle slide right here, when Greg shows up in an apartment to rent an apartment, they want to know that it's Greg, but they don't really care that it's Greg. They care, am I a real person? They want to know, is my credit profile, in North America we have credit agencies like Equifax and TransUnion that say my credit is good, I'm not a bad credit risk. They want to know I validated my driver's license on this device, I checked my face against the driver's license, and they want to know that this phone is my phone. So what we're able to do is click that button to say I'd like to rent an apartment, authorize sharing of those 4 different parcels of data to the landlord, and then the landlord says, yes, you can rent the apartment. And all that happens in a couple seconds to go. We don't want the data to be in the middle. So people hear us say blockchain and think we're bringing all the data into the middle and keeping the data. We're not. We're using it as a transit mechanism to help a user get their data from a place where they have it to a place where they want it to be to prove who they are. And all of this is done with this what I know what I have, what I am kind of factors. So the kind of things that we have to save. So these are the parties that participate in Canada. So some of your data is at your bank. Your bank knows your name, your date of birth, how long you've had an account, that you can log in on these different devices. But there's other parties who know a fair bit about you. So the telco knows that this is my device. So this is Greg Wolfon's device. The SIM is in the device. The SIM hasn't changed for 30 days. The location of the device. And putting these things together, you start to have like chip and pin in the banking world. If I have my card and I know my PIN, there's very little fraud that happens because you have to have the card, you have to know the PIN. If I have to have my cell phone, Greg's cell phone, and know Greg's login to his bank, very hard for someone to become me because they'd have to steal my phone and know my logins. Not just get my login, not just phishing, not just get my phone. They have to do both. But that's bank and telecom. The third one is government. Can I match the face on my passport or my driver's license? And the fourth one is things like credit bureaus and background check agencies. So in Canada, we're doing things like background checks. So I show up to rent an apartment or to get an Airbnb place, I can prove a background check that I'm not a criminal, that I'm not going to steal all the furniture and do all the rest. But all of these are providers of data. And what we want to do is empower that me, that woman in the middle, to share her data wherever she wants to. So in this slide here, it's showing some of the examples. She wants to open a bank account. She can share from another bank where she has an account, her name and address. She can share from the telco that she has this device. She can share that she's validated her driver's license. And in a matter of seconds, she can create an account. Or she can change her address. She can register with the telecom, with the newspaper. When I move, I'd like you to update my address in these places. And the system will, with her consent, update her address or prove that she's trusted for eBay or places like that. Prove she's over 19. So in Canada, we check age. In some provinces, you have to be 18 and some 19. We want to be able to prove you're over 19 and here's a picture of my face, but not necessarily share your name and your address and your weight and all the other details that are in your driver's license. So those are some of the use cases that we're building. I'll actually show you some examples here. Sorry, and these are the use cases. So we use this for account onboarding. We use it for registration for services. We use it when you want to log in to a service. So I show up again for healthcare. So the first time I can prove who I am, and the next time when I show up, I can just put my finger on my button of my bank app and log in for healthcare. I don't have to remember a new username and password. We can verify transactions and maintain accounts or recover accounts from there. So these are kind of the life cycle of what people do with the service. And in Canada, this is the partnerships we have. So all of the banks, the telecoms, life insurance companies, the federal government, and many of the provinces that we work with, universities, credit agencies, and background check, passport, all the other certification levels. So this is the new service. It's called Verified Me, and we called it Verified Me in Canada because we wanted to put it together with the strong brands in the country. So Canada Verified Me, or Royal Bank of Verified Me, or Rogers Verified Me. It's kind of a service mark of what we do. So I thought I'd give some demos of kind of how it works. That's okay. So I showed this one a little bit before. I want to go to an apartment site and I want to rent an apartment. All I have to do is click on the link. It takes me to my bank auth. So authenticate to prove you've got the phone, you've got the account. In this case, I bank with TD Bank. And so it comes up and says authenticate with TD Bank. And then it asks me, so this is all how we meet the GDPR style legislation. We're going to the consumer, and every time she's sharing data, we're saying, are you willing to share this data from these parties to this person for this purpose? So they're always controlling. So it's not Facebook, it's none of that. The user gets to control, yes, I'm willing to share that, and she can click review, or he can click review to see the data that they're sharing. And when they say authorize, that data gets shared to the relying party, and they know that it's trusted. So there's a billing event that happens there, and a relying party can ask for what it wants. So if someone's getting a mortgage for a large amount, they'll probably want a driver's license validation or a passport validation plus a phone validation, other parts. If someone's doing something that's low value, like getting into a bar, they'll probably ask for less to go through. But a relying party can ask for different parts, and the user can consent to what they're willing to share. So this now is showing, so what happens if I'm in person? So I come into a branch or I come into a telco to use it. How does it work? And you can scan the QR code or you can enter your mobile number. But she's showing up at the telco and she wants to get a new cell phone. So all she's able to do with the app is she's able to take a picture of the QR code and a request comes to the phone. So to her phone, and it says, are you willing to share this data from TD Bank, this from TransUnion, and this from your telco with the cellular network to get your new phone account? And when she consents and she authorizes, It says OK here. And on the screen, it says, welcome, Lena, you have your new account. So that, like what was talked about this morning, was how do you do this and make it more secure, but also make it easier for users to use, because users have to use these things to make them work. Like, it's great to put in DNA or put in a piece of hair. It's really secure, but it's too hard for people to do. And this, being in a mobile device, is really easy for a user to do, but it lifts the security bar much higher than it is today. I think I'm still here. Oops, sorry. Maybe. I'm going to try and go back and forward again to get this to go. It might play a video. So this is Sun Life. Sun Life has 127,000 employees, and they have benefit insurance. Their problem was people don't remember their member ID for their benefits, their insurance, and they don't remember their password. So what they did is they basically said, if I want to create a service, you can use Verified Me. It checks the phone, it checks the SIM is in the device, location of the phone, it checks with your bank, are you willing to share this data? And when I consent, it comes back and says, welcome, Jim. You're on the service. That's just a ton easier than it is today. You know, they have hundreds of thousands of calls every month for people who don't remember their member ID and don't remember their password to log in for their insurance because they don't do it frequently, so they can't come through. So it's one of our partners, Sun Life announced recently to work with us on the service. But again, here, all I had to know was my bank and have my phone, and now I can get my insurance services, or I can renew my driver's license and services like that. The next one's health. So we have a challenge with health. We have this free healthcare I talked about. Every different health provider has a different portal, has its own user ID and password, has a requirement because health is so important to us. You have to come in person and prove who you are and get a PIN and create a password. But people like my mother can never remember their passwords. So I'm always having to help, and they can't manage them. So with our service, when you show up here, you can register for the service by using one of your medical logins if you want to, or you can choose one of your banks to be able to log in to the service. And if you use your bank, it'll ask you, is it okay to share your name and address in the bank? Is it okay to validate your health card against the healthcare service? And then you're validated. And then every time you come back in future, it's as simple as putting your finger or putting your face against your iPhone to log in for services, and you don't have to remember yet another username and password. So it takes hundreds of millions of dollars of cost out of the system, and it makes the health care provision much safer, because today, with the username and password, it doesn't work. The user's always coming back to log in again, or doing an email password reset, which is a very insecure bar. All someone has to do is take over my mom's Gmail account, and they get into her health records. So what Canada's trying to do is make that stronger by levering these factors. The third one I talk about is the call center. So I'm on the phone with the call center. It says, please enter your mobile number. I was going to show these demonstrations live on my phone, but I couldn't run a phone from up here because it's not secure enough. It'll push to your phone to say, hey, we're going to send you a message to your phone. Once you send a message to your phone, it says, is it okay to share your information from your bank? So you log in at your bank, and your bank shares back to the call center that it's actually you, and then you can get access to service. So instead of being on the phone to the call center and them asking you questions, what's your mother's maiden name, when was your first account open, things like that, that sometimes you can answer and sometimes you can't, what if you could just authenticate with your bank and say, is it okay to share my data, and then continue the call center call? And that saves, for our federal government, in one service alone, it saves about $100 million a year of cost of trying to identify people on the phone. So it'll take the next person in the queue, so you show up. And this is just showing the validation of a document. So this is an older version. The identity stuff we do now is much better, but generally you take a picture of your health card on the front. It reads, it's a little bit slow. I think it says take a picture of the back. So we're checking validity of the document. We're checking the front and back. We're doing a liveness detection on the face, and we're checking the document against source to make sure that this number and this data actually is Carol and that she matches the document. So you only do this one time, but it's important to be able to check for liveness when registration time. Anyway, we'll come back. Okay. So that's kind of what we built and what's from the conversation this morning about how do we get this going faster within Russia. I think you're on the road to doing some of that now by checking government documents with the telco, by checking the device, by being able to tie your bank login into that. We can make a lot of these services just so much easier for a user. Our view is that whether you're opening a bank account or accessing an account or consent or signing, like do you consent to share your medical data with this doctor? How do you record that in an irrevocable manner? That's what we're trying to do. How do you store information, change your address, prove that you're trusted? But all of this stuff should create a better experience for the user, should have strong identity validation from multiple sources, because our view very strongly is one source isn't enough. Your bank is very strong, but if you add your bank to the mobile operator to know your device and add that to the government to know your face, all of a sudden it becomes much, much stronger. So you get a what I know, what I have, what I am. And we built this on Hyperledger Fabric. So I'll talk a little bit about that. So the way we used to build these things is to have a credential broker in the middle where all the data flows through the center. You take all your data, you're able to share it from one place to another. But we worried about a central point of failure, denial of service attacks, and things like that. So we started to build it again. Sorry, my graphic is a little funny in the middle, but the advantage of building on a blockchain network is that we make sure no data is visible in the middle. So the banks in Canada didn't want secure key or other people seeing data that was in transit or at rest. So if you share your data from your bank to government, there should be no one who's able to see your data while it's in transit. They didn't want a central database of all the data of citizens in there, because if you create a central database, you create honeypots of data that the bad person will go after and try and attack. They didn't want a central point of failure, so they didn't want us to be able to take down the server and then identity for the country for healthcare or getting on airplanes doesn't work. So in the blockchain environment, we have many nodes run by Royal Bank and TD Bank and Scotia and BMO and CIBC. In order to take the service down, you have to take down all the nodes of the network. They wanted this triple blind privacy. So you don't always have triple blind because there's security concerns that happen. You need to be able to break the glass. If there's a problem, law enforcement wants to be able to see the data. You need fraud operations on the network. But you do need circumstances where I don't want my bank to know I'm going for this kind of healthcare, as an example. Like your bank shouldn't know you're going for this kind of healthcare or other parts. So you have to blind the provider from where you're going in some cases. You have to blind the receiver from where the data is coming from. In our case in Canada, the federal government doesn't want to know which bank you bank at when you bring in claims. You can decide to use that or not. But they didn't want tracking and they wanted resiliency. So that's how we thought about the network. Our rules were basically, let's make sure we have resiliency against denial of service attacks. Let's make sure we don't create a big place where all of users' data are, where they'll go after. The bad guys will put a target on it and they'll eventually get to the data. We wanted the consumers to consent every time. So when I'm sharing my data, the consumers have to say, yes, I consent to share my data to this party. We wanted separation of authentication and attestation. So different authentication providers, like the bank and like the telco, and different attestation providers, the government, the bank, the telco, credit agencies, and the like. The triple blind privacy I talked about. Everything's built on standards, so it's all built on OAuth and OpenID connections. And to do all this stuff, we needed blockchain. So there's a little bit on the privacy stuff here, and I don't know how much privacy, the weighting of privacy here, but privacy is starting to be a big thing in Europe. It's starting to be a big thing in North America. Canada has passed strong privacy laws. California just raised their privacy stance. But these are some of the standards that we have to follow. So we have to, in the US, it's NIST, the National Standards Body, and it has SP 800-63-3 that says we want to be able to share data, but we don't want a server in the middle being able to track people. And so we had to be compliant with that law. Privacy by design is the law in Canada to be able to make sure you're private and you don't share more than you need to and you get consent every time. And GDPR, which came into effect in Europe, we have to be compliant with. So a whole lot of rules to be compliant with. This is the quote from Department of Homeland Security. So some of our funding comes from US Homeland Security. As we came to the States, they started to see this is a very good model to share data. So they fund some of the projects we do down in the United States. And everything we build is built on Hyperledger. So Hyperledger is an open source product. IBM is one of the premier members and is a big partner of ours. But the idea is we wanted this to be on an open source platform that lots of folks could use, could adapt, could modify to do what they're doing. And we build our technology, we build Hyperledger below, We use work from IBM to help manage and run some of the nodes. You don't have to use IBM, but they're a great partner to have in this. And then we built a whole bunch of frameworks in the middle on how this works. So as you can see in English here, the attribute sharing framework, how do I share data with privacy? The digital asset provider, so adapters that sit, if you're providing data or receiving data, adapters that go between your legacy systems and the network to share data. The fraud management, the billing, the recovery kind of pieces, we had to build all of those pieces and then applications that sit on top to make it run. And the key principles that we're driving to do this is it had to be efficient, it had to be standards-based, had to have the latest security, and was built in a collaborative environment. So when we talk about how the network works, or what does it do, right, there's two different sides. You have someone who's providing data for you as an individual, and you have someone who's requesting data on the other side. So the digital asset provider could be the bank, could be the government. We leave the data there, and only use that when you consent to share certain types of your data for certain things. So only authorized information that you say can go, it gets authorized, and then the provider will actually provide that data. The consumer is different. So depending on the consumer side, what we give is a toolkit to consumers that they can request different parts. So a bar can ask, are you over 19 or 21, depending on the state, and show me a picture of your face. A healthcare provider can ask for your healthcare number. A bank can ask for your bank and your driver's license and a whole bunch of other kind of details. And the network manages the middle with an application the user has on their phone, so we know what device it is, we know the SIMs in the device and where it goes. And we use the blockchain or the fabric to orchestrate the flows of that and keep the data private. So when it's transitioning from one party to another, it's fully encrypted all the time, and it manages the movement of data. And this is just showing some of the adapters we have. So someone can be a provider of data, someone can be a consumer of data, and in Canada we don't run the nodes. The nodes are run by the national banks, but everyone trusts the nodes that are running and keeps it going. So the kind of standards that we're using, then we're using OIDC for authentication, RESTful APIs, and all the data encryption is done by the adapter, by the bank or the government providing. And the consumer side is a RESTful API, and all the decryption is done on the consumer side. So a key is given to be able to decrypt the data that's sent over without the network seeing in the middle what the data was. I don't know how much more technology you want. So lots of stuff here, but it's generally just saying it's open APIs and open standards around security that we use to build the stack. So we started this in Canada thinking that digital identity was about my name and my address and my date of birth. And what we learned is it wasn't about that at all. It was partially about that, but it was really about the authentication parts, the combined parties giving stronger authentication to prove who you were, and then sharing all kinds of data about you. It was about sharing your credit score, or sharing your background check, or having the federal government share, when I'm getting a mortgage, what was my income for the last 3 years, so the bank can process a mortgage faster with more surety. But all of a sudden insurance companies came in and said, we want to be able to use this network. Sharing economy came in and said, we want to be able to validate who someone is. So I can be on my phone, walk up to a car, prove that it's me, and check my face against the driver's license, then get in the car and drive away with the car. And healthcare is a huge use case. So healthcare, because it's socialized, because it's there, I want to be able to prove who I am, and I want to be able to get access to services. So the network just started to grow, and we're partnering with others in different geographies to build these pieces. So this is an example of some of the uses. So I can set up my account with my bank. I can add my payroll, I can add my credit score, I can add my driver's license, and then from within the app I can rent an apartment, I can get a car reservation, I can set up a new cell phone, those kinds of services. So these are powerful things you can do inside, and it's really called Verified Me. So that's the kind of app that you'll see in Canada in the stores in September. But it's around building this ecosystem. So whether I'm creating a new account or I'm accessing my healthcare, the user carries this authenticator in their mobile phone to be able to go forward. And it's loaded the driver's license and passport validation. It's got account validation. It's got healthcare access and things inside it. And it puts everything in the user's control. So I think that's most of what I have, unless there's questions to talk about what we're doing in Canada, unless there's questions on blockchain. Salavat is here with me. and can answer questions in Russian if you prefer, or I can answer in English if you have questions in English. Thank you. Any questions?
Спасибо, Салават. Вы что-то...
Thank you. Salavat, would you add anything? I would like to answer any questions, please. So, colleagues, please, you're welcome. Your questions. Viktor Shumakov, IBM. So you mentioned blockchain and Hyperledger Fabric and how this technology is really helping to implement, to launch identification for secure key. So in your perspective, what is the most critical thing here when we're talking about distributed network, distributed authentication? Why is it so beneficial? So to clarify it for everyone. First of all, the main target of private blockchain is we look at it as platform where all participants of this ecosystem have to authorize and the blockchain. We have so this is the feature of blockchain, immutable. So immutable data. Any transaction that happens, all peers will have information on this transaction. And this is one peculiarity of blockchain. And another, we use it for, as Greg said, the triple blindness system. So when you send information from supplier to the client of personal data, this information will be hidden. So nor the operator of the platform or other participants of peer or Hyperledger will not see this information.
I have a question. Blockchain size is growing. What is your prediction about secure key blockchain? How its size grows? How quickly?
It's a good question. So blockchain is fairly new, so you have to be careful when you build these networks, how many nodes you have, because when you get more nodes, performance can degrade. So part of what we're doing is working very closely with IBM to make sure we have a closed network. It's a private network, as Salavat said, so in Canada there's only 7 nodes. You can have more, but our view is this has to do thousands of transactions. Like it can't take 10 seconds to do a transaction. It has to be for sharing identity, it can be 1 or 2 seconds. It can't be more, and it has to be many concurrent sessions being able to do it. So we have to scale all the way from Linux boxes up to a mainframe size and be able to show we can handle that many concurrent transactions. But in identity, in Russia, probably similar to Canada, similar to the United States, there's lots of rules around blockchain. So there's lots of people who say self-sovereign, or I can have my identity and I can load it up on the internet and I have it. But the Canadian banks and the Canadian regulators worry, hey, I need sovereignty of data. I need to know all the data for this network stays inside Canada. So the nodes reside inside Canada. There's rules about where data can get shared and where it can't get shared. So there's some interoperability internationally, like we bring in from UK Verify, and we work cross-border in certain cases. But generally, there's rules around where data goes and where it stays. So there's nodes in each country. So Canada has its nodes, the US will have its nodes, Russia will have its own nodes, and then you have rules over where that data sits. And you have people to call if something goes wrong. So the best example is my wife got a phishing attack and she entered her email password into a thing and it took over her email. And like we heard this morning, within 30 minutes, they had mined her email and written a letter to her banker. They created a new Hotmail account and they wrote a letter to her banker saying, hey Daniela, please transfer $50,000 to this account. They took her picture off Facebook as well. She tried to call Hotmail for 2 weeks to get rid of that account. You can't get rid of that account, ever. So there's a lot of notions of self-sovereign, but identity is a really important thing, right? Because it's going to get used to access your health records. It's going to get used for all kinds of things. When you build a national identity network, you have to have who's responsible, who can I call, how do I shut down that identity if it's a fake identity, someone's taken it over. So we kind of have a governing council that sets up the rules within a geography, and then we believe in interoperability international, but that you'll have private networks in each country that keep the data there and have the rules, and how do I recover in the event something goes wrong? Because it doesn't matter how high we build the bar for those of us here in cyber, You have to know, you have to match the face, you have to have the phone, you have to know the password. If there's enough money at stake, the bad guys are trying to get there, so we're just raising the bar. So you have to be able to shut down an identity, recover, find out where it's been. We call break the glass. So a lot of hard work's gone into how do you manage this network once it goes live, which means limited nodes to start, and then we'll get to more later. Behind you, Sala.
Sberbank, Michael Ananyev. My question about the mechanisms of account cancellation. For instance, if I want to stop or close my account in this kind of network, is it possible technically to do? And what about for my personal data not to be able to be used by anyone else? Yes, this platform has the termination function, so-called termination function. And if the person doesn't want to use this account that he created, with a certain bank, then it can be removed. But only the hash can have the information that the data will be removed. The data removed on about the account created, because the bank still will have the personal data, and will be able to and you will be able to create your connections with the bank. But all the ties, as Greg was, telco, credit bureau, they all will be removed. They disappear.
Between GDPR and some of the rules around banks. So the bank is required to keep data for 7 years or 10 years, but GDPR says if a user wants you to delete the data, you have to delete it. So we have to get rid of in the network any sharing, any notion of that individual, and we can, but we can't tell the bank, you must delete that data. So there are contracts that you must adhere to the law. When you share data with a party, they must adhere to the laws if the customer asks it to be removed and do whatever they can. Some can remove it and some can't by legislation remove it. But we have to make sure we adhere when we're sharing the data, that we don't see the data, we don't keep a copy of the data in the network.
Andrei Kaskov, about the Hyperledger. As far as I understood, in this network, you will have several points to authorize new transactions. Actually, that's also the refusal date. So if you attack those points, all the transactions will be stopped. Their sources of data also will be under the same threat. So what is the super advantage here? Because additional transactions, well, instead of giving the data to the insurance company, there will be another additional point of blockchain, which will have potential points of refusal. So for the transaction, well, first you need a request for transaction. You have to obtain a license from the user. I mean, the user that the transaction can be performed, executed, number one. Then you get a request for transaction. Then the request comes to the supplier, and then they decide whether they are to answer the request, to respond. The question was, is it, well, DDoS, there will be no DDoS attack, because if you, the user every time should give you the end. Well, but the network will have the authorization points, which will authorize. If I want to send or request information, I'm ready to give the information, then it goes to the chain, and my transaction can be rejected by the network, for instance, if I'm not authorized, for instance. So this spare operation is another point of refusal or rejection. What do you mean by authorization? I mean, I say that I allow the bank to give my data to the insurance. So then the bank, but this, but for this thing to go to the chain should be authorized. Microphone, please, microphone. Well, to clarify how the Hyperledger Fabric was, it can be many chains, it can be thousands. Well, just try to get aligned in 500 or 700 chains. So the way of consensus, first phase, when it is validated and authorized, the next hash made up on the basis of the previous one and the same combination on 256. If it is okay, yes, then the algorithm, then it's the second phase of commit. Then it's right. So try to change it. Thank you. Questions? you were saying about the unchangeability of the data, and it so happens that if I don't want my data to be read, so you have to block it, right? Correct me if I'm wrong. You mean, what do you mean? I mean, you said that in blockchain.
And the information, the transaction went from the provider to the consumer, that information saved, not the private information about the user.
Не, лучше на русском. Я понял. Вы
So you mean the data is not changed, right? The blockchain doesn't change. That's one of the features of the blockchain. It doesn't change the data, does it? Well, the transaction data doesn't change. Well, the whole story is stored, yes? Yes, and then in blockchain, one of the main features is decentralization, right? And as far as I remember, the Hyperledger is a private blockchain, right? Is it private? And it so happens that you use their network, or you build up your own. Hyperledger is a platform. Yes, it's a platform. It's not just one. You can say that it's a software, as the case, an open source system. So on the basis of it, you build up your own blockchain, right? Right. And in the blockchain should be decentralized. So you have your own system in one place. It's decentralized, but it's private. Only certain participants can have access, but you have the information now. The information is stored by the peers, those who are the nodes. So who are the bases? So the banks, the insurance companies, yes, who is going to be the...
Verified Me network doesn't store any PII. Any PII will be stored on the provider side.
Provider side and sending side. So what we're using it for is to orchestrate the flow between the sender and the receiver, make sure it's encrypted all the way through. But we have a hash of certain parts with salts and things that are appropriate to be able to prove that data was received, it's been unchanged from the sender to the receiver all the way through. And so there's a hash which is, you can't turn back into the real data.
спасибо.
Thank you. Thank you very much. Any more questions? Please tell me, if the device is compromised, then the criminal can command to transfer the data not to the bank, but to the malicious actor himself. What about your technology? How can you combat it? Because it was said that if malware compromised on Android, it's in between you, and instead of the user, it identifies. It authenticates you as a user.
Transition through the device, right? So if someone has malware on my Android device and compromises the device, in order to be able to do that, they'd also have to have my PIN code to be able to be me to share data. But the data is transitioning through the network and not through the mobile device. The device is really managing keys to know that it's actually me when I'm able to share data. So it's not, I think your question was around, is the data going through and can I send it to someone who's not supposed to get the data? So in order to receive data to make a request from the network, you also have to have keys. So Royal Bank or TD Bank, who want to be able to request, is this really Salavat who's coming, they need to get keys to make an authorized request. And if someone who doesn't have proper keys on the network cannot request data from the network.
Correct me if I'm wrong. Then I do understand that the data, the personal data, of course, it goes from peer to peer, but the command to give it to this peer is given by the user from mobile, by PIN code, or. But if the malware is on the device, then the PIN code is remembered by it, and it can, roughly speaking, can authenticate it. Or correct me if I'm wrong. Well, first of all, to authorize in the application, you have to know the password and login of the bank. And then for the login to happen, it goes to the page of the bank. And then the bank will verify by IP location. whether it is not too many people who are trying to identify for fraudulent events they are verifying. Well, first of all, first they have to get through this filter, and then at least he has to know, well, if biometrics to match it, so the person has to, well, to make the fake face like Greg was showing in the president. It is possible, of course, but it leads to, well, it's the level is higher and higher for breaking in. So we use the maximum number of identifiers from the person, the maximum possible to really know whether this is the person who's using the platform. Still, it's a probability approach. If the malware catches it all, the camera and your fingerprint and the PIN codes, if it is on the mobile device, it collects it all, and at some point it will be able to use having all this aggregate of data. It can identify itself as the user, right?
Here is we're trying to raise the bar. We're not saying it will be a zero. It's not possible to become someone. We're right now, the number of takeovers of bank account apps that someone takes over the app, they exist. There's still some that are able to do it. We're adding with the telco capability, and the SIM is in the mobile device, so you can't move it to another device, and we're adding with biometrics. But on an iPhone, we know it's really safe. On some Android devices that are rooted, we're checking to see if the device is rooted. We're checking for malware as we go through. So we have to be careful of those kinds of risks. But the point is to raise the bar to make it harder. If we can have things in a secure element of the device, it's much more secure. And we're getting there on some, like on Samsung devices, but not on all devices. On Intel devices, we're running in the SE processor outside the OS, but not all devices until we can get there.
Okay, thank you.
We have one more last question to ask. Evgeny Yuskevich, my question not related with vulnerabilities, technical vulnerabilities, but about the usefulness and the legal basics. To clarify, using this application in Canada, I can identify myself in case if I drive a car and I have no driving license at all. Is it possible for me to use the device, which has the functionality, to show it to a policeman, for him to know that me is me, without having this physical document, or maybe in a bar, if I want to drink something in a bar? Well, Greg knows better, because I'm more technical about that.
Going is the driver's license should be in the device. You should be able to share it with a police officer who's nearby, and for sure already we can share it in a bar. So we can share, we wouldn't share all the details in the driver's license, but we'd share you're over 19 and here's my face to the bar. So we're trying to minimize data that gets shared. So a bar in the system can ask, are you over the age of 19? Show me your face. A policeman can ask for your entire driver's license. So it's intended to load the driver's license and be your wallet to share it with a police officer for sure.
As far as I understood, the driving license should be in your pocket, right? No. First, you have to have this card, and when I'm get registered and when I use it, do I have to have it physically with me? I mean, the functionality of this application. I would like to understand the legal aspects and legal situation with road inspector, a policeman on the road. If I don't have my driving license with me, I cannot say for Canadian officials whether it's possible to do it. But for instance, if yes, then I'm interested in the legal groundwork. What is the basis of the work of this application?
It's going to be different in different states and geographies because the laws have to change. Like right now, a police officer has to see your physical driver's license. And a lot of places don't have laws to say I can show an electronic copy. In the United States, there's Arizona, there's 2 states that have a mobile driver's license where it's loaded in your phone. And that's what we're working with. So we're working with IDEMIA to load the driver's license into the phone, and then you can share an electronic copy. But you need the legislation to change to allow that to be a valid copy. What we're able to do in Canada is use the driver's license and show we've got a valid copy, and we did liveness detection to open a bank account. We can use a copy to do certain things, but for a legal, like the police pull you over for identity purposes, you have to get the laws to accommodate that, and that takes some time. The general framework in our network when we're sharing, and why it took some time to go, is you have to make sure the network has rules around what you share. So when I consent to share my data, I might be sharing from Royal Bank I might be sharing from Rogers or Bell Canada, the phone company. I might be sharing from the government. The contract that they sign to share data says, number one, the user has to consent to share their data. And number two, the relying party who receives the data has no liability back against them. Because if I'm a bank and I'm going to share data on my customers, I'm going to try and make it as safe as I can. But if I have liability back, if I'm earning $1 and have millions of liability if someone gets in health record, it doesn't work. So it has to be this model. So the whole part of this is technology. As you go to solve it, part of it will be technology, and part of it will be the legal framework, exactly what you talk about. Who are parties who are willing to share information? Who is receiving information? What is the user consenting to when they use this application? And you have to get all of that stuff right. So it protects the providers. It limits the liability of the receivers, because it makes it safer for them. But if we want to have liability, we have to raise the price too high. We want to make it very affordable. Like the login service in Canada is something like 50 cents per user per year for as many uses as a user using government. It saves them hundreds of millions of dollars. If we wanted liability protection, all of a sudden the price would be much, much higher to do that. So we're trying to make sure it's cost effective, but you have to manage the liability and the legals around all of those things. So driver's license is one where we can use it in some cases. We'll get to an MDL standard that says I can load my driver's license in the phone and share it that way, but it's gradual. In the US, it's state by state. In Canada, it's going to be state by state. And I don't know what it is here.
Thank you very much, the speakers, for your interesting presentations and in the interest to the session. So now you can visit our exhibition on the ground and first floor. You're welcome. You will see a lot of interesting things. Thank you.